numbers. 2.1, find square roots and compare real numbers. Perfect squares. What are perfect squares? Well, 1, 4, 9. How am I getting these numbers? 1 times 1, 2 times 2, 3 times 3. Those are perfect squares. 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. All the way up to 12. So a perfect square would be like a 3 by 3 that has an area of 9. 9 is a perfect square. What about non-perfect squares, like the square root of 62? How would I find out what the square root of 62 is? What we need to do is find the perfect square before and after that rational number. So we have the square root of 62. What is the perfect square that comes before 62? Well, 62 would be in between 49 and 64. So the square root of 49 is the perfect square that comes before it. The square root of 64 is the square that comes after it. We're looking for the perfect square before and after the non-perfect square. That means at 7, we have the square root of 49, and at 8, we have the square root of 64. Halfway in between is 7.5. Is the square root of 62 closer to 49, more towards the halfway mark, or closer to 64? I would say it's before 64. So we would say that the square root of 62 is approximately, it's not exact, it's an irrational number that goes on forever, a decimal number that goes on forever. Would say it's about 7.8. It's not 8, it's not 7.5, but it is closer to the 8. So I would say it's approximately 7.8. And that is how you figure out what non-perfect squares are without a calculator. Ordering on a number line. We have 4/3 as a mixed number. That would be 1 1/3. So 1 1/3, 1/3, 2/3, 3/3. So 1 1/3 would be here. That would be 4/3. You use the original number. I used the mixed number to help me figure out where it was, but you use the original number on the number line. Negative square root of 5. Negative square root of 5. Negatives are on the opposite side. And so on a number line, we have negative square root of 1. The negative goes on the outside. 2 times 2 is 4, so the negative square root of 4 would be here at 2, negative 2. So I would say that right after the square root of negative 4 would be the square root of negative 5. Negative square root of 5. The square root of 13. Well, what is the perfect square before and after 13? We have, let's see, 3 times 3 is 9. And then 4 times 4 is 16. So we're between 3 and 4. Here's the square root of 9. Here's the square root of 16. The square root of 13, where does it fall in here? Because we have the square root of 9, 10, 11, 12, 13, 14, 15, and then 16. So the square root of 13 is going to be a little bit off center of here. 9, 10, 11, 12, 13 is 4 away, and 13, 14, 15, 16 is 3 away. So it's a little bit after the halfway mark. The square root of 13. Negative 2.5, negative 1, negative 2, negative 2.5. And then the square root of 9 is here at 3. the square root of 4 is a 2 by 2. The square root of 4 can be broken up into 2 times 2. The square root of 4 is just 2. The square root of 16 would be a 4 by 4. The square root of 16 is 4 times 4, so the square root of 16 is just 4. The square root of 7 is between which two perfect squares? Between the square root of 4, which is 2, and the square root of 9, which is 3. So we're in between the whole number of 2 and 3. Here's the halfway mark at 2.5. The square root of 9 is going to be close. The square root of 7 is going to be closer to 9. So I would say about here for the square root of 7. We're going to say that the square root of 7 is approximately about what then? 2.7. Here's 2.5, so about 2.7. What would the picture look like? We have a 3 by 3. And then we also have a 2 by 2. And it's going to be a little bit more of the 3 by 3, but not all of it. That's what the picture would look like. It's not exactly a 3 by 3, but it's more than a 2 by 2. So we have a 3 by 3, and we have a 2 by 2. It's not a complete square. The cubed root of 64 means that you need 3 of something under the square root. That would be 4 times 4 times 4 equals 64. So the cubed root of 64 is just 4. Now it's 3-dimensional. So this is a 4 by 4 by 4. 4 by 4, and then giving it some width. 4. That is what a cubed root is. A square root is 2-dimensional. A cubed root is 3-dimensional. Now talking about our whole numbers. We know that our whole numbers start with 0, 1, 2, 3 to infinity. Integers also have whole numbers in them.
Jacob Holland to the guidance office, please. Jacob Holland, please come to the guidance office.
But they also have the negative numbers. -2, -3 to infinity. Rational numbers have 0, 1, 2, 3. They have the negative numbers, but they also have fractions like 4.5 and decimals like 4.7. Irrational numbers are numbers that don't repeat, don't end. Decimal numbers, irrational numbers are decimal numbers that irrational numbers are non-perfect squares, like the square root of 5. That means that perfect squares would be over here. Perfect squares could be in the whole numbers. What's the square root of 4? It's equal to 2. 2 is in the whole number. So perfect squares do belong over here. I could also have the perfect square in the integers. The square root of 16 equals 4. So the square roots, the perfect squares belong over here. They reduce down to whole numbers. Non-perfect squares belong in the irrationals. We also have pi is a decimal number that goes on forever. The square root of 5 is a decimal number that goes on forever. It doesn't stop and terminate. It doesn't repeat, so that means repeating decimals also belong here, like 0.3 repeating. So repeating decimals, terminating decimals belong with the rational numbers, and then decimals that go on forever, they don't repeat and they don't terminate, belong here under rational numbers. Rational numbers can be written as a quotient of integers. Rational numbers can be written as decimals that end or repeats. That ends or repeats. Irrational numbers cannot be written as a quotient of integers. Irrational numbers cannot be written as a quotient. Irrational numbers cannot be written as a decimal that ends or repeats. The square root of 24, is that a perfect number? Or is that a perfect square? Or is that an irrational number?